I chose the melanocortin 1 receptor in relation to the substitution mutation of arginine to cytosine on the 67th amino acid chain in beach mice. The melanocortin 1 receptor is also known as MC1R. It is in charge of the regulation of skin and fur pigmentation, UV response, and melanoma risk factor. Specifically, when looking at the mutation of arginine on the 67th amino acid chain to a cytosine in beach mice. The MC1R protein is in charge of the production of pheomelanin. Without the arginine, eomelanin is not being produced, causing the beach mice to have a lighter coat, and in this case, having a lighter coat would be beneficial to the beach mice since they can blend in with the sand better. I consider this as a transcription factor category because when the receptor proteins are coding for the genotype, the phenotype is also being affected. There is an incorrect transcription of an R allele from the arginine to a C allele from the cytosine, resulting in a higher production rate of pheomelanin, which is one of the two pigments that determine hair color in beach mice. Melanocortin 1 is found on the surface of a melanocyte cell. It is a transmembrane protein that can be found in hair follicles of furry animals. The 67th amino acid in the protein chain is where the substitution mutation occurs. Instead of an arginine, which is a polar and positively charged molecule that is relatively heavier than most amino acids, a cytosine is coded for in place, which is another positively charged amino acid that is medium-sized compared to the others, which changes the MC1R protein enough to make it unable to bind to a AMSH, or an alpha melanocyte stimulating hormone, which is in charge of producing eomelanin. The mutated protein is useless since it cannot properly produce eomelanin, making the mice darker and easier to be seen and therefore preyed upon. In my model, I used pennies, but that's not exactly travel friendly. But it also does show more than like a pipe cleaner or something smaller. Also in this model, you can see that it's a transmembrane protein as it goes from the outside of the cell into the membrane and into the inside of the cell. The mutation actually occurs on the inside of the cell at the 67th amino acid chain, which is indicated by a nickel. This would instead be a cytosine and would code for the production of less eomelanin, resulting in lighter skin pigmentation. Thank you.